f of x equals negative x to the fifth plus 5 over 2x to the fourth plus 40 over 3x to the third plus 5. Determine the intervals where f of x is increasing and decreasing. All right, so the intervals where a graph is increasing or decreasing is asking for where the slope of the graph, aka the derivative, is positive, and where the derivative is positive and where the slope of the graph, aka the derivative, is negative. Okay, so we actually kind of know how to do this already. We just have to put it all together. We know how to find the derivative, and we can obviously figure out where the derivative is positive or negative because we know how to find critical points. So critical points is where the derivative is equal to 0 or it's undefined. And you guys told me last week, especially when we're finding absolute max and mins, that the critical points tell us where relative mins can occur. And when you get to a relative min or a relative max, so I'll just draw one here. If this is the relative maximum, we go from increasing, 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 and then once we hit the slope of 0, right, the slope of the tangent line is 0, we change over to decreasing. And then the opposite actually happens with a min, okay? So I'm decreasing, decreasing, decreasing. I hit my slope of 0, and I change over to increasing. So critical points tell us where the max and mins occur. So they will separate the graph into regions of increasing or decreasing, because once you hit one of those critical points at a max or a min, we know that we could be, maybe not always, we could be changing over from increasing to decreasing. All right, so in other words, between critical points, the derivative is either all positive or all negative. Alrighty, let's do one. So here's our original function. So step 1 is to find the critical point. So I'm going to come on the next page. I'm going to rewrite the original function. So we have f of x is equal to negative x to the fifth plus 5 over 2x to the fourth plus 40 over 3 x to the third plus 5. So f prime of x, this is an easy one, is negative 5x to the fourth plus 10 x to the third plus 40 x squared. And we want to know where is this equal to 0. So I'm going to take out a GCF. I'm going to take out, what can I take out? I'm going to take out negative 5x squared. I like the first term to be positive. X squared minus 2x minus 8. This is factorable. So this would be x minus 4, x plus 2. So I just found all my critical points. So my critical points can happen at 0, 4, or negative 2. All right. So now comes the new part. So we found the critical points. Let's determine if they're max or mins. And I actually don't really care for the actual value of the max or min, so I'm not going to make you plug these back into f. I really just want to know what's happening to the left and to the right of these critical points. So, oh, look, I even said it. So I don't care. So remember, you just need a sign. We just want to know if it's positive or negative. So I'm going to make what I call a sign chart. And I'm going to put my critical points on here because that's all I care about. I care about what's happening at negative 2, 0, and 4. All right. So I need to know what the first derivative looks like at these points. So I'm going to choose points a little to the left, a little to the right, because I know if I plug in the actual points, I'm going to get 0. So it's much easier to plug into the factored form because remember, we're just looking for signs. So I'm going to circle this guy. Okay, so if I plug in, I'm going to start easy with 1. If I plug in 1, this term is positive, right? So I have positive times a negative, because 1 minus 4, times a positive. All right, so here I'm negative. All right. Oh, wait a second. This one was negative. Hold on. I missed the negative sign in front. So this is negative times a negative times a positive, so this is going to make this positive. All right. So if I plug in positive 5, because that's a little to the right of 4, that's negative, positive, and positive. Sorry, my kids were just screaming outside. You never know if it's like a scream like they're having fun. Oh, they're trying to catch leaves that are falling, so they're having fun. All right. And now let's go to the left of 0. So if I plug in negative 1, that's still negative, negative, and positive. So that's positive. Okay. And then if I plug in -3, that's negative, negative, negative. So this one's going to be negative. All right. So this tells me where the slope, aka the derivative, is positive and where the derivative is negative. And some of you could probably actually remember from Algebra 2 that because this was x squared right here, the sign wasn't going to change because it was a double zero. I don't know if that's coming back to any of you right now, but we'll come back to that in a little bit. So anyways, I know where I'm increasing, I know where I'm decreasing, so I'm going to write it out. So I am decreasing between -infinity and -2, and between 4 and infinity. I am increasing, now this is important here, I'm increasing between -2 and 0. And guys, remember, I'm not increasing or decreasing when my slope is 0, so I have to take a break. And then in between 0 and 4, I'm also increasing. So we just did an example where we were able to figure out where the function's increasing and decreasing with A, not looking at the graph, and using what is called, I should be coming up to the first derivative test. So let's take I think I have one little note written first. So conclusion. The only place the derivative can change sign is at a critical point, but it doesn't have to change sign. So right here, we didn't change sign at 0, and that's okay. So this is neither a max nor a min, right? Something else is happening there, and we'll get there within a couple days, but it's not a maximum and it's not a minimum. All right, I think some of you might already know what it is, but I won't exactly say it yet. All right, so it can change sign at a critical point, but it does not have to. All right, so now we're up to the first derivative test. So the sign chart we made also helps us find, so it tells us where we're increasing and decreasing. It also helps us identify local or relative, those words are interchangeable, max and mins. Okay, so this brings us to the first derivative test. So if the derivative is greater than 0 on the left and less than 0 on the right, okay, that means you went from a positive slope to a negative slope. You found a relative maximum. And if it's the opposite, if on the left-hand side of the critical point, you're less than 0, that means you're decreasing, and then all of a sudden you switch to a positive slope, you switch to increasing. You have found a relative min. Okay? And then on this one, this is what happened at 0. If the sign is the same on both sides, it's neither a max nor a min. It's actually, I'm not going to go there yet. I want to, but I'm not going to. All right. This is called the first derivative test. In formal words, I usually say make a sign chart, things like that. So if we look at the sign chart, okay, I have it. So if we look at the sign chart for the last example, this is exactly what we did on the first page. We can now determine what's happening at -2, 0, and 4. And this is a classic part of like an open-ended question on the AP exams, like part A or part B, where is find all the relative maxes or something like that. And you would have to, a sign chart is not enough, you'd have to explain. So x equals -2, so we go from decreasing to increasing, right? We went from a negative slope to a positive slope, so -2 is a relative min. Okay. X equals 0, we go from increasing to more increasing. Interesting. All right. That's neither a max nor a min. There's no way I'm finishing before this 15-minute limit. I'm so angry at myself for using this new program. All right. And x equals 4, we go from a positive slope to a negative slope. So we're like increasing, and then we start decreasing. So that would be a relative max. All of this information helps us formulate a graph of f of x. So remember, we do not have a calculator. So if we look, here's what's happening on this graph. So we said at -2, we had a relative min. I do. And we also knew the slope was 0 there, so that's fine. And we were decreasing to the left of that. Oh my gosh, this is so crazy. It's all matching up with everything that we had. And then we started increasing, right? The slope of the derivative was positive. And then at x equals 0, the slope was 0. But we didn't change from increasing. So we're still increasing until I get to this relative max over at 4, and I start decreasing again. So this is called I'm going to say it. I keep saying I'm not going to say it, but I want to talk about it. This is called the point of inflection, and we'll talk more about those at a different point. Um, so the slope right here at this point is 0, but we didn't change from increasing to decreasing. Something else changed, and that's going to be brought up with the second derivative test. But for right now, we'll just call that a point of inflection. All right, let's try another one. So now you're going to have to sketch the graph. The graph isn't going to be given to you. So f prime of x is equal to 12x squared minus 24x. And we find the critical point. So we want to know where that's equal to 0. So I'm going to take out a 12x, left with x minus 2. So my critical points take place at 0 and 2. I'm going to make a sign chart. 0 is important and 2 is important. And I want to know what is happening to the left and to the right of these critical points. So I'll plug in -1, and I have negative times a negative, right? Negative times a negative is a positive. If I plug in +1, this side will be positive, this side will be negative. And if I plug in 3, positive, positive. All right. So I know I'm increasing from negative infinity to 0 and from 2 to infinity. And I'm decreasing from 0 to 2. Okay, I've got that written out. So find the intervals for increasing and decreasing. I did that. Oh, the local extrema. So let's see. So here I go from increasing to decreasing. So at x equals 0, we have a relative max. And then at x equals 2, the opposite happens, right? We go from decreasing to increasing. We have a relative min. So since they want us to sketch a graph, I am going to find some y values. So I want to know what the y values are for my critical points. So I'm going to find f of 0. That's an easy one. I get 0. And f of 2. So what's that? 4 times 8 minus 12 times 4. And that's -16 is f of 2. So I kind of have some sort of an idea as to where things are happening on this graph. Okay, so f of 2, I'm down here at -16 over here. And I know I'm increasing to the right of 0. So I have to be like this. And then I start decreasing. And then I have, and I actually really could, no, I won't. So if I go back to, see, I always say I'm not going to do this, and then I want to do it with you guys. So I take out a 4x squared from the original function, and I'm left with x minus 3, right? So let's separate this. And now go back to algebra 2 when you would analyze functions and not actually the derivatives or anything like that. You knew you had x-intercepts at 0 and +3, and you knew that you bounced at this one, at this 0, and then you went through the x-axis at this 0 because the power was 1 on that exponent. So the algebra 2 stuff still does come into play. So again, guys, my sketch is not great. I could label this point if I really wanted to, but it's perfect for what I know. I'm increasing at the right spots, I'm decreasing at the right spots, and I have my maxes and my mins at the right spots. And that's really all I need at the moment. Okay, so I'm coming up to my 15-minute limit, so I guess I'm going to stop and start a new video because I think I want to do, let me see what the next couple examples, how many more do I have left? Yeah, I'll stop and maybe I'll start a new video. And if so, let's say if you guys think that you're good at this point, you can try the next 3 examples on your own. It looks like the last one does involve the chain rule, so you just have to be a little careful with that. And then just check against my solutions that I have posted. Or if you think you need more help, you can continue to watch the next video that I'm going to make and watch me do the problems. All right, how do I stop this? Okay, I'm back. Still disliking this app, but I will finish, at least for today, on this. The reason I tried it is Mr. Kirkby told me the file sizes are smaller, but I didn't even find out how to download that other one, so it's just on the web. So that's lovely. All right, so let's see if I can do better with this one. So, same exact instructions, just a different function. So find the intervals for increasing, decreasing, the local extrema, and sketch a graph. So I've got to find f prime. And f prime of x is what? 8x cubed minus 8x. And you can see they always kind of come out nicely. So I want to know where is that equal to 0. So I'm going to take out the GCF, which is an 8x, and I'm left with x squared minus 1, which we all know is the difference of two squares. Okay, oopsies. Okay, so I know my critical points are taking place at 0, 1, and -1. So I'm going to make my sign chart over here. -1. And again, I know I said this before, I'm going to say it again. A sign chart is not enough on the AP test as justification. You have to follow it up with a sentence, like my relative mins are this, and things like that. Depending upon what they're asking of you, the sign chart is never going to be enough justification. All right, so I have 4 intervals here I have to find. I'll start with -2, and remember, I'm plugging into the factored form. That's the easiest one. So that's negative, negative, negative. So that's going to be negative. If I plug in -1/2, so that's negative, negative, positive. So negative times a negative is positive. Plug in positive 1/2, positive, negative, positive. So that's negative. And then plug in 2, positive, positive, positive. Okay. So I'm increasing between -1 and 0 and 1 to infinity. And I'm decreasing between -infinity and -1 and between 0 and 1. All right, so I've done find the intervals for increasing, decreasing. Let's talk local max and mins. So I have a relative max. Okay, so here at x equals 0, I'm increasing, increasing, and then I switch over to decreasing. Okay, so I have a relative max at x equals 0, and I have 2 relative mins, right? Relative min at, so here I go from decreasing to increasing, decreasing to increasing at x equals -1 and x equals 1. Okay, so I want to sketch a graph, so I need to know my function values at those points at the very least. Sometimes it's nice to find more, but I've got to find f of 0, which is 1. I've got to find f of 1 and f of -1. Give myself some room here. So f of 1 is 2 minus 4 plus 1, so that's going to be negative, that's going to be positive 1, right? 2 minus 4, do I have a mistake? Oh, no, it's -1. -1. Okay, I thought I had a mistake on my answer key for a second. Yeah, I'm correct. Okay. And then -1 would be 2 plus 4. Dude, guys, I'm losing my mind. 2 minus 4 plus 1 is -1. Okay. Change the color a little bit. And I have -1 is an important point. Positive 1 is an important point. And then let's get these up here. So I have a point here, 0, 1. And let's see what's happening at these points. So up until -1, I'm decreasing. Switch over to increasing. I hit my relative max. I switch over to decreasing. Hit my relative min. I switch to increasing. So this looks like a W here. And again, perfect graph. Doesn't need to be any more specific than that. So aside from me having poor algebra skills on that one was pretty easy. I will do, yeah, I might as well keep going. I'll do 2 more with you. Hopefully you guys can see that. I don't know if you can. So given f of x equals 3x to the 5th minus 20x cubed, find the intervals for, so same exact instructions. So let's find f prime. 15x to the 4th minus 60x squared. Take out your GCF and set it equal to 0. And I'm going to be left with what? X squared minus 4. And once again, we have difference of 2 squares. So again, algebraically, they come out nicely. So let's see. My critical points are x equals 0, x equals 2, x equals -2. So we're going to make our sign chart over here. Find out where are we increasing, where are we decreasing. Okay, so I'm going to start by plugging in like -3. Positive, negative, negative. So that'd be positive, right? Because it was positive times a negative times a negative. Plug in -1. Positive, negative, positive. So that's negative. Plug in positive 1. Positive, positive, negative. So that's a negative. So that stays negative. So we did not change at 0 from increasing to decreasing or decreasing to increasing, either vice versa. Okay, and then I lastly have to plug in 3, and that's going to be everything's positive. All right. So I am increasing between -infinity and -2. and then from 2 to infinity. And then I am decreasing. Remember to take that break at 0, from -2 to 0, and then from 0 to 2. All right, let's find those function values for our critical points so we can get a sketch. So it looks like f of 0 is 0. F of 2, so that's going to be 96, because 2 to the 5th is 32, times 3 is 96, minus 160, because that's 20 times 8. So that's -64. And then f of -2 would be -96 plus 160. So that's +64. All right, so this is going to be an interesting looking graph here. I'll get some sort of a scale on here that makes a little bit of sense, because obviously it's not small y values. So we're going to have to label this slightly. So I'm going to make my y scale be by 50s. So that's 50 and 100. And I'll do -50 and -100. So again, do your best. It's just a sketch. And my x scale is still going by 1, so I should label it -1, -2, +1, +2. I'm going to change my color. All right, so my critical points, I'm going to plot them first, and then I'll worry about the increasing, decreasing. So f of 0 is 0. And then what else did we say? F of 2 was -64, so that's right about there. And f of -2 was +64. All right, so from up until -2, I am increasing. So I must be looking something like this. And then this could take you back to algebra 2 with the end behavior. We could always do end behavior checking, but that's not really necessary anymore. And then at 0, I do have a slope of 0, but I don't change over from decreasing to increasing. So I just kind of am going to flatten out a little bit. See how I flattened out there? And then once I get down here, I do change over to increasing. So my graph looks something like that. Okay, and last problem. All right, so this is the one that I said involves a chain rule. Same exact instructions though. All right, so I have to find f prime. F prime of x is equal to 2/3 times x squared minus 1 times 2x. So derivative, oh, I forgot my exponent, hold on. -1/3 times the derivative of the inside, which is 2x. Ah, silly Mrs. Bucko. Imagine if I had done the whole problem. 4x over 3 times x squared minus 1 to the -1/3 power. Okay, so this one's what? Slightly trickier to find the critical points. So I'm going to take my two parts and set them equal to 0. So this one's easy. So x is equal to 0. That's a critical point. And then over here, it involves a little more thinking, I guess. X squared minus 1 to the -1/3 is equal to 0. So I'm going to raise everything to the +3. I'm sorry, to the -3, right? If I did it on this side, and I could do it on this side, I have x squared to the first, x squared minus 1 to the first is equal to 0. And then this would be, you could either do difference of two squares, or I'm going to just do it quickly. X squared is equal to 1, x is equal to plus or minus 1. So those are my critical points. So x equals 0 is a critical point, x equals 1 is a critical point, and x equals -1 is a critical point. Those will actually be nice and easy to plug in, though I can tell already looking at the original function. But first, let's figure out our increasing, decreasing. All right, so my critical points are -1, 0, and 1. All right, so I'm going to start from left to right, plugging into the derivative, remember. So if I plug in -2, please remember, a negative exponent does not turn a number into a negative. It just moves it to the denominator. So if I plug in -2 squared, that's positive, minus 1. So this is all positive, but over here is going to be negative. So it's negative times a positive is a negative. I plug in -1/2. This becomes negative. This becomes negative. Negative times a negative is a positive. Plug in +1/2. Negative times a positive is negative. And last but not least, I'm going to plug in like 2. And these are both being positive. Okay. So I am increasing between -1 and 0, and from 1 to infinity. And I am decreasing from -infinity to -1, and then from 0 to 1. All right. So I'm ready for my graph. Oh, wait, I didn't find these points yet, did I? So I have to find f of 0 f of 1, and f of negative 1. And then I'm ready for my graph. Okay, so let's do it. F of 0 is going to be 1, right? If I take it, I do to the 1th, so it's negative 1 to the 1/3, but then I square it. Oopsies. So that's going to be positive 1, because anything squared is positive. If I plug in positive 1, I'm just going to get 0. And if I plug in negative 1, I'm going to get 0. Those are super easy points. All right, let's get this graph. And then we are done. Well, I'm sorry, not done. You guys still have some work to do. But at least my the videos and the notes are done. Okay. So let's get these key points on here. Negative 1, 0, and positive 1. So up here I was at 1. So that's a point, and that's a point. Now let's figure out our increasing, decreasing. Up until negative 1, I was decreasing, and then I switch over to increasing, and I have a relative max right here. Ooh, I think I skipped labeling out my maxes. I got to go back and do that. And then I switch over to increasing. All right, so let's fix that real quick. So this graph looks awesome, but I did skip this part right here. All right, so I have a relative max at, and I actually have the values now, which is nice, so 0, 1. And I have two relative mins. So a relative min at negative 1, 0 and 1, 0. And I slightly think I forgot that in the last example too. So this is full credit right here. Hopefully we're all okay with it. Involve the chain rule. It was slightly more complicated, but still not that bad. Did I skip? I did skip it on this one. So I have a relative max at negative 2, 64. And I have a relative min at 2, negative 64. So I didn't have anything at 0. 0 was neither. And you don't have to state that. It's not asking for you to state the neither points, but it's important to point out. Did I skip it in this one too? No, I wrote that. I didn't put the values. This would have been 0, 1. And this would have been negative 1, negative 1, and 1, negative 1. All right? But remember, they say find the maximum value, then they're looking for the y value. If they just say, like, where do the max and mins take place, that's just looking for the x value. So just always pay attention to those directions. All right, guys, that's it for this video. You guys have some stuff posted, some practice problems. I think it's 10 of them. So have fun. Bye-bye.